Hi there, this is Math 6 Unit 4, Lesson 4, How Many Groups? Part 1. We're going to be playing with some blocks and diagrams to think about division with fractions today. Okay, so here we go. Alright, so first of all, it says write a multiplication equation and a division equation for each statement or diagram. So in our first one, it says that we have 8 $5 bills that are worth $40. Alright, so in this case here, we might say something like, if I had 8 bills, and they're each worth $5, I could then show that there was a total of $40 available, right? Using my 8 times 5 to get to $40. That's one possible way of thinking about it. In terms of a division equation, I could say, well, I have $40, and if I divide that $40 by 8 people, each person would end up with $5. So it's a way of writing a division equation. That would work okay as well. So when we have whole numbers like that, it seems pretty straightforward. It's when we get to questions like 2 and 3 where things seem to be a little bit more different. And that's because we're talking about division with fractions today, all right? Where things are just not quite as clear as we might like them to be, okay? So for number 2, there's different ways of saying this. So first of all, we see that there are 9 thirds. Now a third is 1 over 3, but so there are 9 of these inside of 3 ones. Well, the number 3 is the same as 3 ones. If I have a 1 plus a 1 plus a 1, that's a 3. So we're saying that there are 9 of these things inside one of those things. Another way of thinking about that is, if I take my 3 and I divide it by a third, that's not going to work out. Sorry about that. If I take my 3 and divide it by a third, yeah, then what I end up with, yeah, I'm good, is I end up with 9. That's what we're saying. If I take the 3 and I divide it into thirds, right, my 3 ones divided into thirds, I end up with 9 of those things. So 3 divided by 3, or by 1/3, sorry, is 9. Okay, as a multiplication problem, we might write something more along the lines of 9 times 1/3 equals 3, and that would be okay for a multiplication problem. All right. When I come over here to number 1, we can see we have our whole is 1 right here, and we're dividing this into what looks to be 1, 2, 3, 4, 5 groups, thinking back to our last lesson. So I could think of this as saying, if I have 1 and I divide that into fifths, right? Into, let's say, remember these are like we talked about our bags before, our jars of jelly or jars of jam, and this is how many cups would be in there, right? So let's say I had 1 whole cup of jam, and I wanted to put 1/5 of a cup inside every serving. How many servings could I create? Well, that would be 1 divided by 1/5, or in other words, we'd have 5. Now that 5 matches our 5 jars down below. So we have 1 divided by 1/5 equals 5, right? And so another way of thinking about this, if we think about multiplication, is this could be also 5 groups times 1/5 is going to equal 1, and that works as well. So there's different ways of thinking about it, but that's kind of the idea, because we're talking today about division with fractions, and so that's how we set those ones up. Let's take a look at activity number 2. In activity 2, it says reason with pattern blocks. We're going to take some pattern blocks, like we have here, and I have some here as well, and answer some questions. It says if a hexagon represents one whole, so a hexagon is one whole, this is one whole right there, what fraction does each of the following shapes represent, and be prepared to show your reasoning. So the first one says, what does one triangle represent? So if I take a triangle here, and I compare that with a hexagon, if the hexagon is a whole, the question is, what fraction of that hexagon does one triangle take up? And what we might notice here is that we, if you remember from previous things, we can actually get 1, 2, 3, 4, 5, 6. We can actually get 6 triangles on top of one hexagon, right? So 6 triangles is the equivalent of one hexagon, which means that one triangle by itself, in terms of how this relates to the whole hexagon, one triangle as a fraction is 1/6 of the entire hexagon. All right, that's one triangle. When we look at B, B says, what about the rhombus? Well, when I put a rhombus down here, I could stick one right there. And what I might notice, maybe I need a couple more to take a look at it here, is for the rhombus, a rhombus, 3 rhombuses can work together to form one hexagon. So if I only have one rhombus, then I end up having 1/3. Why 1/3? Because I have one of the 3 possible parts there. So I would say that a rhombus represents 1/3 of a hexagon. When it comes to the trapezoid, same idea here. The trapezoid is made up of 2 parts, right? So 2 trapezoids creates 1 hexagon. So if I have 1 trapezoid, I'm having 1 out of the 2 in order to make the whole. And that's where we are with that. Okay, so 1 triangle is 1/6 of it, and a rhombus is 1/3, and a trapezoid is 1/2. If I had 4 triangles, well, we know that a triangle, it takes 6 triangles to make the whole. So if I have 4 of them, then I have 4/6 of the triangles, or 4/6 of the whole there. And again, you could show that by putting your things down like so, right? Drop those in there. We have 1, 2, 3, and 4, and there's still space for 2 more. This would be representing 4/6. If I had 3 rhombuses, well, rhombuses of these guys, we've already established that 3 rhombuses actually complete the whole thing. So 3 rhombuses would be the same as saying I have 3 rhombuses out of 3 kind of slots or spaces for them, which is the same as 1 whole. If I had 2 hexagons, well, that's a little different, right? So here's a hexagon, and here's a hexagon. So let's see, if 1 hexagon is 1, and I have 2, then it seems like in terms of a fraction, I have 2 out of 1, right? Because this is the whole, and I have how many of these? I have 2 of these, so I get 2 out of 1, which is the same as 2. And if I have 1 hexagon and a trapezoid, so something along these lines, 1 hexagon and a trapezoid, then in terms of the whole that I'm utilizing, I have 1 whole, and I have 1 trapezoid, which is a half. So I have 1, and I have a half, which is the same as either 1 1/2, or I could say that that's 3/2, but you're probably going to stick with 1 1/2. All right, so that's utilizing our different shapes there to show how a fraction represents a part of the whole. So the next question, it says that here are Elena's diagrams for 2 times a half equals 1, and 6 times 1/3 equals 2. Do you think these diagrams represent the equations? Explain or show your reasoning. Okay, so what she's saying here is that I have 2 times a half. So she's pointing out that in this case here, in this case, this trapezoid is a half of the whole, and this is a half of the whole. And what she's saying is that because I have 2 of them, when I multiply the 2 halves, I end up with 1 whole. And we would say that we agree with that. That is correct because that's 1 whole rectangular shape. No, rectangular, sorry, hexagon shape. All right, on the other one, she says 6 times 1/3 equals 2. This is taking the rhombus, which we know to be 1/3 of the hexagon shape. So 1/3, 1/3, and these are all 1/3s. And I have 6 of those there. And if I have 6 times 1/3, you end up with 2. Well, looking at this, do you end up with 2 whole hexagons? You certainly do, so we would agree with this one as well. And of course, if you just multiplied it out, you would do something like 6 times 1/3, which we're not asking you to do, but just to verify for those skeptics out there, we have 6 times 1 is 1, 1 times 3 is 3, and then you have 6/3, or 6 divided by 3, which is equal to 2. All right, let's move down to number 3. It says use pattern blocks to represent each multiplication equation and recall that a hexagon equals 1 whole. So this is saying 3 times 1/6 equals a half. Now back to what we did before, we said that in the hexagon form, 1 triangle had a value of 1/6. So if we had 3 of the triangles, 3 1/6 shapes, how much of the hexagon would that actually cover, right? So here are 3 1/6 segments, and I put those in place, and so how much of the whole hexagon are we covering? We are indeed covering half of it right there. So that's going to be a true statement here. It does indeed cover half. Now for this next one, it says 2 times 3 over 2 equals 3. So that's going to be, I have two groups of 3.5. It's going to equal my whole number 3. So let's think about, what is 3 over 2? Well, the half piece is the trapezoid right there, right? That's a half piece right there. So that's my half piece. So if that's my half piece, and I have 3 over 2, which is 1, 2, 3 of them, 3 over 2, so I get 3 halves right there. And then it says I'm going to multiply that by 2. Let me get some more pieces out of my bag. Okay, so let me get another group of those. So here's another group. Here's another 1.5. And then how many holes do I end up with? I end up with 1, 2, 3 holes right there. So this shape of 1.5 or 3 halves times another 3 halves does indeed equal 3 holes when I group them all together. And you can see that there with the shape. So that's how these 3 halves work when I multiply it to get rid of the 3 right there. So we would agree with that as well. Answer the following questions. If you get stuck, use pattern blocks. Okay, so how many halves are in 4? So again, let's think about the shape. How many halves are in 4? So if I took the pattern blocks here, 1, 2, and 3, 4. Put it like this because I don't have a lot of space here. And we'll put it aside. Let's see if we're on the frame for picture. Yep. All right. So how many halves are in 4? Well, a half is the trapezoid. So I end up with 1, and I end up with 2 for each one, right? So I'd have 1, 2, and if I copy this over, I'd have 3, 4, 5, 6, 7, 8. So how many halves are in 4? We would say that there are 8. And again, you could show that by, if we drew our picture out real quick. Like this. And there's my 4 hexagons, and if we cut them in half, like so, we end up with 8 pieces altogether. 1, 2, 3, 4, 5, 6, 7, and 8. All right. Next one says, how many 2/3 are in 2? How many 2/3 are in 2? Now that one's a little different to think about. Okay, so if we think about 2, and this is 2 holes right here, and we're talking about 2/3. 2/3. Now 2/3 is a little bit different, right? So how do I get 2/3 out of this here? Well, 2/3 is going to be, in this case here, we take a rhombus and a rhombus, and I have a 2/3 of that is filled in, right? So the question would be, how many times can I put 2 rhombuses in this hole and have it work out? Well, I know I could do it on that one time. And here's another group here, that's 2. So I can get 2 so far. Can I get any more? That's the tricky question. And when you take a look at it, you have these spaces, but what do you notice? I can take a 2/3 again and drop it in there. So this is 2/3, 2/3, and 2/3. So in total, I have 3 of those, don't I? I have 3 groups of 2/3, because that's a 2/3 group, that's a 2/3 group, and that's a 2/3 group, based upon the hexagon being the whole. All right? It's maybe a little bit trickier to see there, but that's one way of thinking about it. Okay? Now, how many 1/6s are there in 1.5? Now again, that 1/6 is that triangle, so how many triangles are there in 1/2? Let's just sketch this one out real quick. So we have this like that, that's our hexagon, and then we have, it's 1.5 hexagons, so we're going to draw the trapezoid here. So how many triangles are in there? Well, a triangle is made up, 6 triangles fit inside 1 hexagon, and 3 triangles fit inside of 1 trapezoid. So in total, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 of those all together. Okay, So that's kind of the idea so far with what we're looking at. So in summary of today, so some problems that involve equal size groups also involve fractions. Here's an example. How many 1/6 are in 2? We can express this question with multiplication and division. We can say what number times 1/6 will get you to 2, or we can take 2 and divide it by 1/6. Either way, you end up with 12, right? Because this is our hexagon once again. It's our hexagon. And we're saying that we're taking the 1/6 triangle pieces, and how many of those are in 2? Well, when you divide it up like so, what do you have? You end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of those. So you end up with 12. So 2 divided by 1/6 is 12, and 12 times 1/6 is equal to 2. The pattern blocks just help us see that to make more sense of the problem. So it's good to have those to play with a little bit. So this flows the rest of the way to show you that if the hexagon's a whole, a triangle is 1/6, how do you get to 12? And that's part of the summary review right there. Okay, so that's it for today. Hope that helps you out a little bit, and take some time to work on your homework, and we'll check back in just a minute. All right, homework time. It says a shopper buys cat food in bags of 3 pounds. Her cat eats 3/4 of a pound each week. How many weeks does one bag last? Okay, so we're gonna draw a diagram here for what this might look like. Okay, her cats need 3 pounds a week. She has a 3-pound bag. So if you're thinking about a diagram like I did before, this is like this kind of question. We have 3 pounds, right? And we know that we have all this cat food. And what we know is that every time she serves her cat food, it's a 3/4 of a pound. Now she does that again and again and again, but we don't know how many times the shopper can do that before they run out of food. They're going to take the 3 pounds and divide it into equal segments of 3/4 of a pound, again and again. In essence, we're doing 3 and we're dividing it into 3/4 segments, and that's going to tell us how many times we can break this up, how many groups we can get out of that. That's the idea. So to solve that then, what we're looking at is saying, okay, well, what number, as a multiplication problem, you'd be thinking about what number can I multiply by, well, we can multiply by 3 to get 3/4, or we can multiply by 3/4 to get 3. Okay, so what number times, yeah, let's do this. Let's do what number times 3 will equal 3/4. Okay. No, I don't like that way. Let's do that way. Yeah, nah, I don't like that one. Let's do 3/4 times a number. What's this? Let's do 3/4 times what number? This one times what number here? Here's our question mark. It's going to be equal to 3. And that's a little bit better to think about, I think, for you guys. All right. So to do that, then we got to think about what number times 3/4 gets to 3. Well, the best way of thinking about that, and again, there's some shortcut ways to do these things, and I understand that. But in our case, if I took a picture here, let's take a picture of a box, right? Back to some shapes. So here's a box, which is broken up into 3/4. Okay, so a box there, not 3/4, but it's actually fourths. And a box here, a box here, and a box here. And let's pretend that they're going to have 3/4 of a pound of food each week, right? So 1 whole pound is going to be 3 of these. So I actually only need 3. Sorry. So here's my pound of food. So 1, 2, 3 pounds of food. So on day 1, for example, they need 3/4. So let's make this into 1, 2, and 3. So day 1, they're going to eat that much. Fantastic. On day 2, we need 3/4. So we're going to go 1, 2, 3/4 there. And on the next day, they need 3/4. So we need 3 of the 4 squares. 1, 2, 3. And on the final day, they need 3/4 again. So we go with 1, 2, 3. You see, each of those squares is a 1/4 square because of how we set it up. So in essence, how many colors did we use? We used 4 whole colors. We have the yellow, which is day 1, the green day 2, the pink day 3, and the blue day 4. So looking back at our equation here, does 3/4 times 4 equal 3? So does 3/4 times 4 equal 3? Well, 4 is 4 over 1. Those cancel out, so you have 1 over 1, and 3 does equal 3. That's going to work out just fine. So we've already written for B, write a multiplication division problem equation. We did that there. And then multiply your answer in the first question by 3/4. Did you get 3 as a result? If not, revise your work. So for our thing here, our first answer was 4. If we multiply 4 by 3/4, do we get 3? Well, that becomes 1 over 1, and it equals 3. We're okay, and we're good to go. All right, so a lot of extra drawing into there just to kind of explain it, but it helps sometimes to see a little visual for how that can work out. Let's look at number 2. Use a diagram to answer the question, how many 1/3 are in 1 2/3? So here's a whole and 2/3, and the question is how many 1/3 are there? Remember that a rhombus like this is actually a 1/3 unit, right? It's a 1/3 unit. So I could actually draw another one right here, and here, and here. And what I really have is a third, and a third, and a third. So the question then is how many 1/3 are in there altogether in this whole thing? We would say there are 1, 2, 3, 4, 5 of them. 5 of them there. Now the math way, what we're doing here is we're taking the 1 2/3 and we are dividing it into 1/3, aren't we? So this becomes 3, 4, 5/3 divided by 1/3. Okay, and we know that that's going to equal 5. How that's going to work out. Again, if you learned a trick and you went, well, let's take the second one, flip the second, and multiply that whole business there. Yes, that's true. That's 1, 1, 1, and then we're left with equal to 5. But it's most important to be able to see why is that 5? Because if I divide this up the right way, if I divide 1 2/3 into 1/3 segments, I come up with 5 in total. That's why this actually goes with that. Okay, which question can be represented by the equation something times 1/8 equals 3? Okay, so I'm going to take this and write it on the next page because my choices are over here. So we have something times 1/8 equals 3. Okay, so if we think back to our pictures before, this is like saying I have 3 of something, and it's here, and I'm going to break it up into 1/8 segments, 1/8, and I don't know how many are going to be in here, 1/8, and that's going to tell me how many segments I'm going to have, or how many servings perhaps. So I'm taking, in terms of this one here, I have 3 as my total right there, right? So what I'm doing is I'm taking my 3 and breaking up into 1/8 chunks to find out how many there are. What am I doing? I'm finding out how many 1/8 are inside of 3, which is choice C there. Number 4, write 2 division equations for each multiplication equation. All right, so we can write this like this one. We can do 6. We could do 6 divided by 2/5 equals 15, or we could do 6 divided by 15 equals 2/5. Okay, we can then do 8 divided by 4/3 equals 6, or we can do 8 divided by 6 equals 4/3. And here we can do 14 divided by 7/8 equals 16, or 14 divided by 16 equals 7/8. Number 5. Noah and his friends are going to Music Park. The total cost of admission for 8 students is $100, and all the students share the cost equally. Noah brought $13 for his ticket. Did he bring enough money? So what we're saying is that 8 students times some price for the tickets is going to cost these guys $100. So to find out how much that ticket's going to cost, we basically take the 100 and we divide it by the number of people that are going. So 8 goes into 100 one time, which is 8. That's 2. Goes into 20 two times, which is 16. We have a remainder of 4. And it goes into 40. Put a decimal there. 5 times, which is 40. So each ticket's going to cost $12.50. If Noah brought $13, then he's going to have enough money. Yes, he does. Because the ticket's only $12.50, about 50 cents change. And since it's an amusement park, he won't be able to buy anything else. Lucky him. All right, number 6. Write a division expression with a quotient that is greater than that is less than that, and is between this and that. So write a division expression with a quotient that is greater. Okay, so if we want to have a number, an answer that's bigger than that, then we can just do 9 divided by 0.001. Okay, it's a bigger number, okay, a big answer. Less than that, we could do 7 divided by 0.001. And if we want to be between, this is 0.001, this is 0.10, then we would do 8 divided by 0.01, right? That's going to be between there, put the 1 in that spot. And there you go. And one more to go. Find each unknown number. All right, so for letter A, we have 12 is 150% of what number? Let's take a look here. Okay, so 12 is 150% of what number? So we take 150%, think about this, we have 100% of a number. Well, okay, we got 12 is 150% of a number. So that's going to be 150%, which is 150 over 100, times whatever that number is going to be, is going to be equal to 12, is the idea. Okay, that's 150% of a number is equal to 12. So 150% is 1.5, and we can call this one here x for now, and that equals 12, or 1.5 question mark. So if we divide 12 by 1.5, then we end up with 8. So we would say 8 is going to be the answer there. The way of thinking about that another way is to say, if I took this out and I drew a picture here, and I have 100%, which is a 50 and a 50, so if 100% is right here, and this is going to be 50%, 150, I have my number 12, and I know the whole thing is 12, and I see it's broken up into how many sections? 3. So 12 divided by 3 is equal to 4, which tells me that each section here has a value of 4. So 100% is going to be 4 plus 4, which is 8. For B, it says 5 is 50% of what number? Again, let's do our little diagram here. So here's 100%, and if we said that this is 50%, so half of it, so 5 is 50% of what whole thing? Well, if 5 is half, then put another 5 there, combine that together, you end up with 10. And 10% of what number is 300? So again, we take our tape diagram if we wanted to here, right? And if I broke this up into chunks of 10%, 10, 20, 30, 40, 50, 60, 70, 80, and 90, 100, and if each one is 10%, and 10% of what number is 300? And so if each one of these segments was 300, then I'd have 300 times 10, because there's 10 of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, would tell me that it's 3,000, so the whole thing has a value of 3,000. All right, and finally, and number D, 5% of what number is 72? So 5% of what number is 72? Okay, so again, we take this here, and we can break this apart like so. Okay, and we break this up in terms of 5%. 5 times 20 is 100. Would you agree? So if I broke this up into segments that are 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 5% of what number is 72? If each of these little segments was equal to 72, Then I have 20 of them. 72 times 20 would give me my whole thing. So that's going to be equal to 1,440. And for E, it says 20 is 80% of what number? Okay, we can go here, fill this out here. We have 20, 40, 60, 80, 100. And if we're going to do 80% is right here, to this point, that's 80% to there. And this is 20. So this whole value right here is 20. So we have, we have 1, 2, 3, 4 segments. We do 20 divided by 4, tells me it's 5. So each one of these has a value of 5. That's my 20, because 4 segments there. I know there's one additional segment here, so we add that on. And so the 100% would be all of them to combine, which is going to be 25. All right, and that's it for today. Hope that helps you out a little bit, and we'll see you next time.